All right, we're in chapter 6, topic 1. Page 340. In problems 1 through 4, determine which of the given numbers are solutions of the given inequality. So we're doing inequalities. Do you know anything about rules for simplifying inequalities? They're the same as simplifying equations with one exception. Anyone remember what that exception is? Well, we'll figure it out here. If you don't know the rule, watch what you can do. Every place there's an x, you just insert the number. So we put 1/3 in there, and we get 3 times 1/3 is 1 plus 1. Is that less than 2/3 plus 4? Is 1 plus 1, is 2 less than 2/3 plus 4? Yes or no?
Yes.
Yes. So let's try 4. Let's put 4 in there. 3 times 4 is 12, plus 1 is 13. 2 times 4 is 8, plus 4 is 12. Is 13 less than 12? Boy, that's a... Yes. Why is that printing so big? I don't know why. Yes. There we go. No. What's the next one after 4? 0. Did I put 0 in there? I don't know why. Let's put 0 in there and see what happens. 3 times 0 is 0 plus 1. Is that less than 2 times 0 plus 4? Is 1 less than 4? So 0 would be yes, wouldn't it? And then, what's the next one? 3. Let's try 3. Put 3 in there. 3 times 3 is 9, plus 1 is 10. Is 10 less than 2 times 3 is 6, plus 4? Is 10 less than 10? No. So you just plug them in and check them. Or you can just simplify the inequality. That's what I'm doing here. Simplify. So I take this, all simplify means is you take the complicated statement and make it easier to read. So the first thing is I say I want the x's on one side and the numbers on the other. So I go -1, -1. Now I'm down to 3x is less than 2x plus 3. Then I subtract the 2x over here to get it on the other side. And now I'm down to x is less than 3. Now that's easy to read. See, I took all of this and turned it into this by the process of simplification. So now I just come and look at my choices again. What are my numbers? The only numbers that'll make a true statement are numbers less than 3. So that would be 0 and 1/3. You follow me? I could simplify it and then just compare my answer with the 3 numbers. Or if you don't like doing simplification, you can just plug the numbers in and see which ones work. But we have to learn to do simplification, so you might as well learn that process. Number 6, determine which of the following are solutions of, wow, that is a mess, isn't it? Agreed? Okay, let's just think about how to simplify that. Just look at the big picture and say, well, I mean, when I look at these things, the first thing that bothers me is that fraction. Would you agree? That fraction's bothering me. So guess what? I get rid of the fraction by taking both sides times 5 over 1. That is so cool. Watch what happens. Now I end up with 1 in front of this and 10. So now I've turned this whole thing into this simplified problem right here. You follow that? So you can always clear out fractions by using reciprocals. Now I've got 3x minus 2 is 10. To simplify that, I just add 2 to both sides, and I get 3x equals 12. I'm almost home. So that's times, so I divide by 3, and I end up with x equals 4. So now I go back. Now see how much easier that is than all of those, plugging all those things in? I go back to number 6 and say, okay, x has to equal 4. So a doesn't work, -1 doesn't work, 0 doesn't work, 2 doesn't work, and 4 works. Isn't that a lot easier than plugging all those numbers in and doing all that math? Isn't it? So what did I do here using this option that's on page 333? What did I do here that's making somebody nervous? Does everybody understand these steps? What's 1, 3, and 5? Oh, that's from page 333, where they talk about the steps you go through. You might even, if you don't remember this, if it's been a while since you've done it or no one ever taught you that, just go to page 333 and copy the steps down. And I didn't use step 2 or step 4. I just used step 1, step 3, and step 5. You follow the process? If you copy that process down and have it sitting by you where you can look at it for a reference, then you just say, this is the process I use to simplify an expression. And all you're doing when you simplify an expression is just somebody started with x equals 4, and then they just started messing it up. They just started to complicate it by adding stuff to it. Just like they said, hey, let's say 3x equals 12. Let's multiply by 3, then let's subtract 2 from both sides. You see what's going on? They just keep messing it up. Then they give you what they messed up and say, can you find what I started with? And that's really all simplification is. 7 through 32 says solve. What does it mean to solve? Well, number 8 says x minus 5 equals 8. So what they're saying is, what number minus 5 would equal 8? And the answer is what? 10 minus 5 is 5. 20 minus 5 is 15. So it's somewhere between 10 and 20. 10 minus 5 is 3. 20 minus 5 is 15. What minus 5 is 8? But see, if I take the simplification process, I go to simplify x minus 5, I add 5 to both sides. How do you undo subtraction? By addition. How do you undo addition? By subtraction. How do you undo multiplication? By division. You understand what I'm talking about? Sometimes the reason books don't explain it this way is what I'm saying to you is not necessarily good grammar, but we're not in grammar class, we're in math class. So I'm trying to help you wrap your head around the process and whatever words you choose to use to describe the process, those words are acceptable to me. We're not writing poetry here, we're doing math. So whatever words you choose and how you choose to express them, those are going to work. Number 10, 3x plus 1 is 4. So the first thing I do to get rid of plus x, I go plus 1, I go minus 1, minus 1. And now I end up with 3x equals 3, so I divide by 3 to undo multiplication, and there's my answer. X is 1. I've just solved it. What number do I put in place of x to make a true sentence? 1. So that's what it means to solve those things. Number 12. Okay, they just messed it up a little more. Big deal. Let's just start somewhere, and that's what page 333 talks about. It gives you a process to follow. So it said plus 1, so I go subtract 1, subtract 1. And now I've got 3x on the left side and x minus 4 on the right. So now I got x's on both sides. Well, see, since this is 1x, I go minus 1x and minus 1x. What's 3x's minus 1x? What's 3 times x minus 1 times x? 2 times x. And 2 times x equals negative 4. So how do I undo 2 times? Divide by 2. Divide by 2. And I get x equals negative 2. And that's the solution. I just solved it. Negative 2 is the only replacement for x that makes a true statement. Are we having fun yet? You didn't like this the first time you saw it, and you're not going to like it this time either. But maybe the first time you saw it, the people didn't give you time to kind of wrap your head around the whole process. If you just are rushed through it, you go, I don't get it, just forget it. So it might be that after we get through talking through this, you'll want to go back and read page 333 and read through this material and just give your mind time to digest the process. Can you tell I have those steps from 333 kind of ingrained in my head, just like those magic numbers that are square roots? So since you might not have that, get a piece of paper and write those steps down. Not necessarily the words in the book, but words that make sense in your own mind. Number 14, again, what? I always do this. I want, in my mind, my approach is, I want the letters on the left side and the numbers on the right side. That's just the way I like to do it. So that means on the left side, I get rid of the numbers, minus 3, and now I'm left with 2x equals 3x minus 4. Then I want the letters on the left side, so I go minus 3x, and I get negative x is negative 4. So I divide by negative 1, and I get x equals 4. So once I have a procedure in mind, a process in mind that I'm going to follow, then it's like I'm just going to follow my process. I'm not looking to find the answer. I'm just going to follow my process, and the answer is just going to jump off the page at me when I'm finished, when I finish simplifying it. You follow what I'm talking about? Are these words making any sense to you? Or is this like I'm speaking a foreign language? You're not going to tell me. It's Monday morning, and this is not my favorite topic for a new chapter. All right. Maybe I can help you. Number 20, they just get to be more fun the longer we go. Okay, see, there's only so much the guy can do So back to page 333, and see step 2 says combine like terms. So here's 13a and a. So that just becomes 14a. You follow what happens? I look at each side and put the like terms together. See, the guy's going to keep trying to make it look complicated when all he's doing is some little step, and I just do one step to undo it. And over here was 5a and 3a, so that becomes 8a. So now I've got a problem that I've seen before. 14a minus 6 equals 8a plus 3. So what do I do next? You go, well, I'd like to subtract 3. I know you would, just because that's easier than adding 6. But what did I say is my procedure for doing this thing? I want the letters on the left, the variables on the left, and the numbers on the right. That's just my preferred way of looking at it. I mean, you could put the letters on the right and the numbers on the left, and it would still be true, because x equals 6 is the same as 6 equals x. So it doesn't matter which way you read it. I've just developed a system that I feel comfortable with, and that's what I want you to do. Look at page 333 and develop a procedure that you say, I'm comfortable with this procedure, and I can do this over and over and over and over again. And that's why it might not hurt to have a little note card with those steps from page 333 written down, just kind of as a reminder of what you're going to do to work through it. So now I add 6 to both sides. And all of a sudden I'm down to 14a equals 8a plus 9. Does everyone see where I'm getting these answers? Because 3 plus 6 is 9. So now I'm just about there. I've got a's on both sides, so I go minus 8a, and I'm left with 6a equals 9. Well, I'm just one step, because that's multiplication. So how do I undo multiplication? Divide by 6, and I get a is 3/2. 9 over 6 reduces down. 9 over 6. Little tree, 3 times 3. A little tree, 3 times 2. And 3's cancel, so it's 3 over 2. I know you can do that in your head, but I just think these little trees are cute. So I like to build them. Number 30. Okay, see, all he's doing here is just, as we get to the end of this set of problems, from 7 to 32, he just tries to complicate it. So he's complicated this with 2 things. He's made it complicated with fractions and parentheses. So the first thing, I can't believe I just said this in my head. The first thing I want to get rid of are those fractions. I'm sorry, fractions. You are my friends, but you complicate things. And I have 1/2 and 2/5. So you understand? I'm thinking if I want to get rid of both fractions at once, I'm going to multiply both sides of the equation by 10. Everybody see that? And if I have a balanced equation and I take both sides times 10, it's still balanced, isn't it? And what's 10 times 1/2? 5. And what's 10 times 2/5? 4. Now you see what I've done? I just cleared out those fractions. Sorry, fractions. But you really were making this look like a mess. But I still like you. So now I've got this parentheses. Okay, so let's get rid of the parentheses. Does everyone remember being taught the distributive principle? See, watch this. I don't know why this gives people trouble. 5 times 6 plus 4. What's 6 plus 4?
10.
What's 5 times 10?
50.
So that equals 50. Now see, that just doesn't look right. I mean, I look at it and my mind goes, that looks like that's too big. Well, the distributive principle says, what's 5 times 6?
30.
30. What's 5 times 4?
20.
20. And I add 30 and 20, and what do I get? 50. Do something to make your mind accept that principle. Even if it means writing on a little piece of paper and saying you have to look at it and say, well, sure enough, it comes out to be 50. And I know 6 plus 4 is 10, and 10 times 5 is 50. When I go, in other words, I know 10 times 5 is 50. Well, distributive principle, 30 plus 20 is also 50. So now, with that concept in mind, I come over here and I go, what's 5 times 3x minus 1? 15x, 5 times 3x, minus 5 times 1, minus 5. Everybody follow that? What's 4 times 3x plus 1? 4 times 3x, 12x. 4 times 1, plus 4. So now I've got this pretty well. I mean, I've made a lot of progress in terms of simplifying this. I've gone from all of this down to this little statement right here. 15x minus 5 equals 12x minus 4. So now you see where I am? I'm down to the place where I'm saying I want the letters on the left. I mean, me personally, I want the letters on the left. I want the numbers on the right. So I go, well, then add 5 to both sides. And then I come up with 15x equals 12x plus 9. Then I subtract 12x from both sides, and I end up with 3x is 9, and I'm just about home. Undo multiplication by division. And I guess I should erase this here. And go divide by 3, and I get x equals 3. Everybody see what's going on? Well, we've just reviewed and hopefully mastered the art of solving equations or simplifying. 33 to 38. Okay, I don't know if this is new to you or not, but this is kind of a fun process. Even though it's just like, so what did we do? See, when you're doing simplifying or solving, you keep taking complicated stuff and make it look simpler. When it says to solve for the indicated letter, I'm not going to find an answer. See, over here, solving meant I come up with one final answer, like x equals 3. Down here, I'm going to solve, well, look what 34 says. Solve this whole thing for h, which means I want to get h by itself. I want h to equal something. And there's the answer right there. So I'll just circle I'll put a box around the answer, because once I finish the process, would it be fair to say my answer looks more complicated than what I started with? But that's because I'm not really solving it for a number, I'm rearranging it to get a different number other than v by itself. You go, why do you do that? It's just mental gymnastics. Why does a person go tumbling across a mat? Why do they run and jump from one corner to the other? They want to get to the other corner. Then why do they turn around and run back to the other corner? What is going on here? It's gymnastics. So that's what we're doing. We're doing some mental gymnastics, mathematical gymnastics. And of course the process is, if I want h by itself, can you see? I want to get rid of 1/3. Oh, we'll just take both sides times 3. And then I get 3v equals pi r squared h. See what's happening? In other words, I'm just going to take it a piece at a time and start to rearrange it. And if h is times r squared and times pi, then I'll divide by pi, and I end up with 3v divided by pi equals r squared times h. And then I divide by r squared, and I end up with my final answer. 3v over pi times r squared equals h. And I've done just what they told me to do. I've solved the formula v equals 1/3 pi r squared h for h. 38. P is by itself, and it equals all of this. And they want me to solve for this. So that means I want this to be by itself. So I need to get rid of the b minus b. And I need to get rid of the s minus s. So what do I end up with? P minus s sub 1 minus b equals s sub 2. You follow the process? Whatever, decide where the s sub 2 is. The one I want to solve for, I look to see what's with it, and if it says it's plus b, then how do I undo plus b? Minus b. If it says it's plus s sub 1, how do I undo plus s sub 1? Minus s sub 1. You follow the thinking process I'm doing? I'm just doing the reverse operations. I'm getting rid of it on one side, so it'll show up on the other side. Number 40. The ideal height of a man is related to his weight by the formula W equals 5h minus 190. And what they say? Solve for h. That's the first thing they want me to do. So I want to get h by itself, so I add 190 to both sides, and then I divide by 5, and now I have w plus 190 divided by 5 equals h. Everybody see where I got that? So I've done the a part of the assignment. Now b says, if you weigh 160 pounds, what should your height be? I don't think I like this problem. I'm thinking how much I weigh. $220 plus 190 divide by 5. What is that? 0, 1, 4. I should be 80 inches tall. That's disgusting. So you're telling me I weigh too much? I'm telling you, you have a bad formula. So stretch me up a little bit. Man. And okay, I will admit, the doctor keeps telling old people, you gotta lose some weight, gotta lose some weight. You know how to lose weight? It's easy. Just walk around being hungry all the time. That's it. As soon as your stomach says, I'm hungry, feed me, you say, not today. You'll have to live off the fat of the land till I get my weight down to where I'm at the ideal height. And you just keep walking. And you say, boy, I should like to have some potato chips. Sure you would. But instead you're going to eat one tiny little orange, clementine, and that's just going to make your stomach just that much more. And the more it hurts, the more you lose weight. No pain, no gain, or loss, whatever you're looking for. And after a while, I get sick of it. I say, I just don't like your formula. because I don't like going to bed hungry and waking up hungry and then being hungry all day long. But I know if I do that, now I will admit, okay, the month before I go see my doctor every year, I walk around being awful hungry for a few days so I can bring my weight down. He says, well, Tom, you're making progress. Good for you. And then after I leave, I go to Burger King and buy me 2 of those Whoppers for $6. Just pig out and going, back to my own standard of living. And I know I grew up eating junk food, so I'm just going to be a junk mess for the rest of my life. Oh, and then my family says, we'd like to have you here a little longer. I said, okay, I'll make a few sacrifices, but I'll tell you this much, I am not going to eat cardboard for the rest of my life just to stay alive for another 10 years. I might go hungry a few times just to be a little healthier, but, and I should confess to you, okay, I'm very cheap. My whole family laughs at this. I have clothes that fit me. If I start gaining so much weight that they won't fit, and I think I'm going to have to go buy some new clothes, I go to the store and see what they want for new clothes, and I'm going to lose some weight. That's ridiculous. Plus, I'll save on the grocery bill too. Number 42, let's get back to math here. The area of a trapezoid is given by this formula. Did you know that? The area of a trapezoid is 1/2 times the height times parentheses the bases, the top base and the bottom base added together. You didn't know that. Well, it doesn't matter. It says solve for h. So if I solve for h, first I multiply by 2, so I have 2a equals h times a plus b. And then if I want to get rid of the parentheses, okay, now I could just come over here and I can say, hey, if 2a equals h times a plus b, I can just divide both sides by a plus b in parentheses and a plus b, and I'm done with it. I have h equals 2a over a plus b. But if that makes you nervous because you say, no, I was always taught to get rid of the parentheses. Okay, just go HA plus HB, and then subtract HA minus HA. So that comes over here. So now you have 2A minus HA equals HB. And then you divide by H, and you see it's the same place. No, you're not. Oh, B. Oh. I'm not solving for H, I'm solving for, what did they say to solve for? B. Oh. Erase that. Erase that. Why didn't someone tell me? I was trying to, you say, how could you misread that, Tom? Easy. Which is easier, to solve for H or to solve for B? Solving for H, so I just took the easy way out. Okay, so now you have to do it this way. So then so now that you've multiplied, because I'm solving for B, then I end up with B equals all of this. And I suppose now they're going to give me a problem. If the area of the trapezoid is 60, so I put 60 up here where A is, and the height is 10, and I put a 10 down here where the H is, and side A is 7, and I put a 7 in place of A, then I have 2 times 60 divided by 10 minus 7 will equal B. 120 divided by 10 is 12. 12 minus 7 is B, so B is 5. See what you're doing? Just plugging in the numbers and then doing the math. Because they told you A is 60, H is 10, capital A, and small a is 7. Number 43, solving inequalities. Okay, where's the rule? 6 is less than 8. Everybody agree with that? 6 is less than 8. Let's multiply both sides by -1. I don't know why I didn't put that in parentheses. -1. There. So, -1 times 6 is -6. Go back to blue. And -1 times 8 is -8. Is -6 less than? Is -6 less than -8? Look at a number line. Here's -6. Here's -8. -8 is less than -6, which means, in other words, -8 is less than, to the left of, -6, which means -6 is greater than -8. But this says -6 is less than -8. Yes? And here's the rule that you have to write down if you don't remember it. That when I multiply or divide by a negative number, I have to reverse the inequality sign to make a true statement. So all the rules for simplifying equations apply to inequalities, except when you're multiplying or dividing by a negative number. A positive number doesn't mess anything up. But if you're multiplying or dividing by a negative number, as soon as you do that, you have to switch the inequality sign. So watch what that means. I'm just going to divide these by -2. So as soon as I say that, I have to switch this to the other direction. You follow me? As soon as I say I'm going to divide by a negative number, I come down here and switch the inequality sign. And then -10 divided by -2 is 5. And -6 divided by -2 is 3. And sure enough, 5 is greater than 3 on the number line. Here's 5. Here's 3. 5 is greater than 3. Okay? So, write that rule down. If you forget it, your answers will be messed up. They'll be going the wrong direction. So now, with that rule in mind, let's do number 48. Follow the same rules for simplifying. I want the letters on the left, the numbers on the right, so I go add 3 to both sides. And then I end up with 3x is greater than 2x plus 4. And then I subtract 2x from both sides, and I end up with x is greater than 4. So I've solved it, except, what does it say? Find the solution set. As soon as they say solution set, they want me to put it in this cute little format here. That's a solution set. It's the set of all x's such that x is greater than 4. That's called set notation. Here's why that's important. On the test, at the end of this chapter, they'll have a problem like this, and they'll say, what's the solution set? If they say, okay, if the question says, what's the solution is x is greater than 4. What's the solution set? The set of all x's such that x is greater than 4. And they'll ask the question both ways to see if you know the difference between when you put it in this cute little box and when you leave it standing alone. Number 50. Letters on the left, numbers on the right. So I do numbers first, -8, -8. So now I have x is greater than or equal to 2x minus 9. Minus 2x minus 2x, negative x is greater than or equal to -9. I divide by -1. So what do? Reverse the sign. And I end up with x is less than or equal to 9. And the solution set is right there. Okay? Don't forget that step. If you forget it, when you check your answer, you'll say it's backwards. Oh, that's because I forgot to reverse it. Number 56. What do I see here that I'm going to clear out? Sorry, fractions. I'm going to take both sides. times 4 over 1. And I'm going to end up with x plus 4 is less than or equal to 3x minus 4. Everybody see that? See how quick clearing out those fractions simplifies things? So then I minus 4, minus 4. Now I have x is less than or equal to 3x minus 8. That gives me negative 2x is less than or equal to negative 8. And divide by negative 2, and that reverses the sign. X is greater than 4. And there's my solution set that they want me to give. Number 70 is the same kind of stuff. 72 is the same kind of thing. No, 72, look what it says for problem 72. It says b is less than 0. That means b is a negative number. Okay? Now I just need to keep that in my head. I can go ahead and do all this work and simplify, and then I finally get down here to, I have this right here. B times x is greater than 2b. Once I get through simplifying all this, I end up with this. But I divide by b and divide by b. And what did they tell me that b was? A negative number. So I have to reverse the inequality sign and go x is less than 2. Because they told me to remember that b is a negative number. I can just simplify with b till I get to the end, and then have to make sure that when I'm doing this inequality thing. So you got to watch for that. Number 74, it's time to do some application problems. Look what 74 says. Find 15% of 60. So I go 15% of 60 is empty box. I put an empty box there, so my head goes looking for something to put in the box. And 15%, I don't multiply with percents, I change them to decimals. Of means times, and 60. So what's 0.15 times 60? Get your calculator, comes out to be 9 equals x. So what am I supposed to do? 40% of 80, or no, 50, find 15% of 60? I just did. It's 9. 15% of 60 is 9. Number 76. See, I told you before when we ran into some of these, I don't like 4 or 5 different ways to work 4 or 5 different kinds of problems. I just want one process for everything. So I just go to 76 and I'm going, here's what it says. 8 is what percent of 4? So I come down here and put 8 is equals what percent, I put that in a box, question mark, of is times 4. How do I simplify this? Divide by 4, divide by 4, and I end up with 2 equals, let's get that out of there, 2 equals some percent. So 2 over 1 would equal what over 100? 200? So 2 is 200%. Okay? Number 78. 20. Where'd it go? 20 is what percent of 30? 20 is what percent of 30? I put down 20 is equals what percent? Empty box with a percent sign. Of means times. Have you got that fixed in your head yet? Is equals, of is times. So I divide by 30 and divide by 30, and I end up with 20 over 30. 2/3 equals empty box percent. 2/3 equals what over 100? You go, I don't know. What's 2 divided by 3? No, it isn't. 2 divided by 3 is 0.6666 dot 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 dot. So how do I change this to a percent? Move it over, whoops. Come on, give me some red. Move it over 2 decimal places, and it becomes 66.6%. Number 80. 10 is 40% of what number? 10 is 40% of what number? So my empty box is over here. Of is times. 40% is 0.40. So 10 divided by 0.40 equals the box. What's 10 divided by 0.40? 25. So 25 is my number. There you go. And if you want to check it out, 40% of 25 is 10. Take 25 times 0.40 and you get 10. Number 82. I've got 280 million tons of something, pollutants released into the air, and 47% of this, so 47% of this amount is carbon monoxide. 47% of what amount? Oh, this amount. Aren't they talking about the 280 million tons? So I go 0.47 of means times 280 equals carbon monoxide. What's 0.47 times 280? 131.6. Now I would just change that to 132. Number 84. The price, the sale price was 90% of the regular price. You see how I'm taking the words they give me in the book and I'm trying to abbreviate them so I can make a mathematical sentence. Everyone see where I got SP was 90% of RP? And I use these letters so I start making the transition from all those words on the page to math. And then what's SP? $18. What's the regular price? I don't know. That's what I have to find out. So I go 18 equals 0.90 of means times the regular price. And if 18 equals this times that, then 18 divided by 0.90 will give me the regular price. What's 18 divided by 0.90? Everyone see why I'm dividing? How do you undo times? Divide. Divide by 0.90. I just wrote it out like this because I thought it looked pretty. And it comes out to be 20 is the retail price, or the regular price. And check it out. What's 90% of 20? 18. So sure enough, I worked it right. Number 86. The loan company loans the Adams family $40,000. So the loan was $40,000. The purchase price of the house was $48,000. What percent of the purchase price is the loan? Now watch this. What percent becomes my box? Of means times the purchase price, that's $48,000, is equals the loan, $40,000. So what percent would be 40 divided by this 40? I would divide both sides by 48,000. And I end up with 40 divided by 48 is 0.833, which equals, move it over 2 places, 83.3% or 83%. Number 88. Maria wears a size 7 shoe. What's her foot length? Let's go to blue. What's her foot length? How would I know? Oh, for women, what's the formula for women? S equals 3L minus 21. And what does S stand for?
Shoe.
Shoe size. So I put 7 in here equals 3 times L minus 21. So add 21 to both sides. 28 equals 3L. Divide by 3, and L is 9 1/3 inches long. You figured out what ladies like to do? I'd say if your foot's 9 1/3 inches long, you wear a size 9 shoe. No, I wear a size 7. Give it a rest. And what do? Us guys, we like to have our feet bigger, so we just kind of up it a little bit. Number 90 has the same kind of problem for men, so make sure that you choose the right formula when you're working these problems. And on the test, there'll be one of these on the test. And guess why some people will miss it? They'll pick the wrong formula. Because what do you think? On the test, what's he going to do? He's going to put the formula first. That's the wrong one. He just does that. Trying to catch you, making a mistake. 94. What's 94 say? Has a whole bunch of words. Okay. When the variable cost per unit is $12 and the fixed cost. So the variable cost per unit is $12 and the fixed cost is $160,000. See, I don't even know what they're talking about, but I don't care. I'm just doing the math. I've taken all these words and extracting information that I'm going to operate on mathematically. The total cost for a certain product is, so the total cost is this big formula. Okay? If the unit price is $20, a unit price is $20. The revenue is 20 times N. You see where they're giving me all this information? They're just telling me stuff. What's the minimum number of units that must be sold to make a profit? To make a profit? To make a profit, R needs to be greater, the revenue needs to be greater than the cost. Agreed? What's R? R is 20N. What's C? That big old long formula. C is 12N plus 160,000. So I subtract 12N from both sides, and I get 8N is greater than 160,000. Divide by 8. N has to be greater than 20,000. So what did I just figure out? How many units do I have to sell to make a profit? 20,000 units. You say, why do you have to sell so much? Because the equipment, the cost is this $160,000 machine that says I better crank out 20,000 units or I'm not going to make any money. I think that's enough of this. Stop when you get to 97, and your test is up here if you want to correct it, and I will gladly help you figure out what you need to do to fix it. In the meantime, I'll shut this